Okay, optimisation. This is one from our worksheets, I think. We have a cylindrical can that we know has to contain a volume of 200, and we want a minimum surface area. Maybe we're minimising the amount of tin because we're reducing the cost. Whatever it is, we're minimising the surface area. Okay, we're given the volume, so let's think volume of a cylinder. Volume of a cylinder. Volume is area of the base, so it's a circle base, so it's pi r squared. Area of the base times the height, so clearly it's pi r squared h. And we're told that the volume is 200, so we get 200 equals pi r squared h. We want to minimise surface area, so clearly we want a function that says surface area. Surface area, I've got two circles, so I've got pi r squared, but I've got two of them, and I'm going to add to that the area around the outside, which opens up to be a rectangle. The length is actually the circumference of the circle, which is 2 pi r, and the width of the rectangle is this height. And the question asks to minimise surface area, so we know we want to get the function surface area, differentiate it, set it equal to 0, but we can't differentiate it because we've got a couple of variables here, so we need to think about it first. We want to get rid of r or h through the use of this thing here, because we have this relationship between r and h. You can see that we're just going to isolate this h to sub in, so let's just go over this way. H equals 200 on pi r squared, and I'm going to put that h in here. So by substitution equals 2 pi r squared plus 2 pi r times h is 200 on pi r squared. I've written that in a way that makes it easy for me to cross out my pi's, cross out my r's. So 2 pi r squared plus 2 times 200 is 400 on r. So that's a function from a surface area, just in terms of r. Now I can say minimums happen at a stationary point, therefore we want to find the gradient function, which is SA dash. SA dash is 4 pi r minus, you can just refresh your memory on that simple differentiation there. And now we're going to go stationary points, slope equals 0, set SA dash equal 0, and let's come back up the top. So we've got this SA dash equals 4 pi r. And we're going to set SA dash equal to 0. 4 pi r minus. And we're solving for r. We don't want r on the bottom, so let's multiply everything by r squared. 0 times r squared is 0. 4 pi r times r squared is 4 pi r cubed, and that's just our 400. Get the 400 to the other side. Divide by 4. R cubed equals 100 on pi. I'm going to leave that SA there because I think I'm going to need it later and I don't want to rewrite it. I'll probably forget it. So here, R will equal the cubic root, because it's a cubed here, of 100 on pi. And we can get rid of all of that. because I'm pretty sure the question says to find the minimum surface area. So I was hunting for a function that said surface area equals, and now that I know my radius of what gives me the minimum surface area, I'm going to go, now my surface area is 2 pi times r squared. Well, r is the cubic root of 100 on pi, and I want to square it, plus 400 on the cubic root of 100 on pi. It might look yucky, but we have calculators, so let's not stress too much about it. We're going to whack that in the calculator just the way it looks. Potentially here you could even just put that to a decimal and bring your decimals in here if that's too scary for you. It's all good. Okay, when we whack that in the calculator, where is my calculator? I did it before. We get 189.32. Possibly there's units on that as well. I can't remember what the question says, but put your units squared, square meterage, because we're talking about surface area. Last but not least, let's just think, potentially I might ask you to validate something. If we think about that function before, it's pretty hard to graph, so my only option here might be to say mathematically confirm that it is a minimum. So mathematically we're looking at the second derivative. So we had before that SA dash was 4 pi r minus 400 on r squared. So SA double dash is 4 pi minus, well, that's going to go back to a plus with the 2 at the front, 800 on r cubed. Okay, so what is our second derivative where r equals the cubic root of 100 on pi? Well, that's a positive number, that's a positive number, and clearly that's going to have to be a positive number, so a positive plus a positive. Because it's positive, I am a happy parabola, positive. That means, therefore, it's a minimum. Therefore, we have mathematically verified that that r is a minimum for that surface area. Okay, that was super fun. Hope you enjoy it.